Part 1. Why AI is starting to hit a communication wall. Recently, the AI industry feels less focused on how powerful a GPU is and more focused on how GPUs talk to each other.
That shift has become pretty obvious lately. Modern AI is not really a single ultra-powerful GPU world anymore.
A few years ago, the whole discussion basically ended at NVIDIA wins.
Back then, raw GPU performance was the center of the industry. But now, as AI models become enormous, GPU to GPU communication itself is becoming a bottleneck.
And the scale is getting ridiculous. OpenAI, Meta, and xAI all talk about clusters with tens of thousands of GPUs now.
The industry is clearly moving toward massive GPU clusters. Meta alone is reportedly building AI systems at the scale of hundreds of thousands of GPUs.
Honestly, that sounds unstable. At that scale, something is guaranteed to break.
Modern AI training works by having huge numbers of GPUs exchange data simultaneously.
And adding more GPUs just increases the communication load, right?
Exactly. Now the challenge is not only how fast a GPU can calculate, it is also how fast the system can move data. Even small communication delays can slow the entire system down. AI data center expansion is rapidly increasing networking demand.
Which explains why companies like Broadcom and Marvell suddenly became major AI stocks.
Especially Broadcom. Its presence in AI networking, AI ASICs, and optical connectivity has expanded rapidly.
But doesn't that mean only big tech can really win? Tens of thousands of GPUs are impossible for normal companies.
That is being debated a lot. Modern AI development increasingly depends on whether companies can maintain gigantic infrastructure systems.
Honestly, some AI companies are starting to look more like infrastructure operators than software companies. But we have always used electrical communication before, right?
Yes, but modern AI pushes everything to extremes: communication volume, heat, power consumption, and transmission distance.
People always talk about GPU power usage, but networking power consumption looks huge too.
It absolutely is. Large AI data centers are starting to consume enormous power just for communication infrastructure.
And copper connections get hot, weaker over distance, and less efficient. That sounds terrible for large-scale AI systems.
Which is why the industry is moving toward optical communication.
Still, I think people oversimplify this. It is not just replacing cables with light. The manufacturing difficulty and cost are probably brutal.
That is important. NVIDIA, Broadcom, Cisco, and AMD are investing in silicon photonics, using light directly inside semiconductor systems.
What surprises me is how AI news shifted. A lot of headlines now focus more on heat, power, and networking than on the actual AI models themselves. Part 2. Why Broadcom and Cisco are suddenly so important. AI stocks are not just about companies making AI models anymore. Networking companies are exploding too.
The market has definitely widened. Now it is not only about how to build GPUs, but also how to connect GPUs efficiently.
Broadcom earnings calls lately feel completely different. A few years ago, it barely felt like an AI company. Now, every sentence is about AI demand.
Especially because Broadcom is tied to AI networking, AI switches, optical connectivity, AI ASICs, and multiple big tech companies. Broadcom extended its AI chip supply partnership with Google through 2031.
2031 is wild. That is not temporary AI hype. That is companies planning infrastructure years ahead.
Broadcom is also expanding AI partnerships with Meta.
Honestly, Broadcom feels less like a semiconductor company now, and more like a company wiring together the entire AI industry. And every time GPUs improve, the communication problem gets even bigger.
Exactly. More GPUs means more traffic, and AI systems increasingly depend on moving gigantic amounts of data simultaneously.
Which means scaling AI is not only about compute anymore. You also need networking, memory, cooling, packaging, and power, all working together.
That is why recent AI infrastructure spending has exploded so quickly. That is why networking, optical links, and AI switches are suddenly becoming critical technologies. AMD, Broadcom, NVIDIA, Microsoft, and OpenAI have all joined efforts to develop next-generation optical interconnect standards for AI clusters.
OpenAI joining networking standards discussions says a lot. Even AI labs are now worrying about physical infrastructure.
Cisco also recently announced AI-focused networking chips targeting NVIDIA and Broadcom's market.
The companies that used to power the internet itself are suddenly back at the center of the AI industry again. Part 3. Has AI shifted from a compute race to a connection race? At this point, AI feels less like building smarter models and more like keeping gigantic systems stable.
That is becoming increasingly true. Raw GPU performance alone is not enough anymore. Now the focus is shifting toward how efficiently massive GPU clusters operate together.
AI companies still do not look interested in slowing down. Every earnings call sounds like build bigger clusters.
Especially among the major players. Meta, Microsoft, OpenAI, and xAI all continue pushing toward larger-scale AI systems.
That worries me a little. Once everybody committed to scaling, the industry lost the option to stop.
Modern AI systems move enormous amounts of data simultaneously between GPUs. As clusters scale larger, traffic increases dramatically.
Every additional GPU creates more synchronization problems too. That scaling curve looks brutal.
Large AI systems require thousands of GPUs working together at the same time. Even small delays can slow the entire cluster down.
Which means just add more GPUs stops working eventually.
That is why connection speed matters so much now. Latency itself is starting to affect overall AI performance.
That completely changes how people evaluate semiconductors. 2 years ago, everyone only compared GPU specs. Now discussions include bandwidth, interconnects, latency, and scaling efficiency.
Exactly. Recent AI systems depend on moving data efficiently, not only increasing raw compute.
Every time one bottleneck gets solved, another one immediately appears. First, GPUs, then HBM, now networking.
That is why NVLink, InfiniBand, Ethernet, and optical interconnects have become central to the AI industry.
Still, isn't NVIDIA becoming too dominant again? If they control GPUs and networking, the ecosystem gets dangerously concentrated.
That concern is spreading across the market. Broadcom, AMD, Cisco, and Arista are aggressively expanding into AI networking infrastructure.
Now every AI bottleneck turns into a new investment theme. That part feels almost unstable.
Markets are increasingly trying to predict what breaks next before shortages happen.
Which explains why cooling companies, networking companies, and power equipment companies suddenly became AI stocks too. A few years ago, light moving inside chips would have sounded like science fiction.
Now it is becoming a practical engineering necessity, especially because communication power consumption is rising so quickly.
AI headlines increasingly focus on heat, electricity, and networking, instead of only model intelligence.
Large AI systems are starting to hit physical limitations. Electrical signaling creates more heat, more power loss, and more inefficiency over distance.
Which means scaling AI further becomes harder even if GPUs improve. That is a very different problem from what people imagined 2 years ago.
Exactly. The bottlenecks are increasingly physical. That is why Intel, TSMC, and Broadcom are accelerating investments into silicon photonics.
The market is not only investing in today's winners, it is trying to predict which technology becomes essential next. That is why AI investing feels so chaotic right now. Part 4. Final thoughts. Light may become the next AI infrastructure layer. What surprised me most about this topic is that we started with GPUs and somehow ended up talking about heat, networking, electricity, and optical systems.
That shift says a lot about where AI is heading. Modern AI is not evolving through software alone anymore. Now, the limiting factors are increasingly physical.
That changes how the whole industry feels. A few years ago, AI sounded lightweight, just smarter software. Now the scale feels completely different.
AI systems are scaling so aggressively that communication itself is becoming a major engineering problem. Power consumption, heat, latency, and synchronization all increase as clusters grow larger.
The strange part is that the industry still keeps accelerating anyway. Every company sounds convinced that larger AI clusters means better AI.
That belief is still driving enormous investment. OpenAI, Microsoft, Meta, xAI, and Google all continue building larger infrastructure.
Even though the costs are getting ridiculous, at some point, these companies stopped behaving like software startups. The spending now looks closer to national infrastructure projects.
That is why networking is becoming so important. AI performance increasingly depends on whether massive GPU clusters can exchange data efficiently.
That completely changes how people think about semiconductors. A couple years ago, most discussions stopped at which GPU is fastest. Now people compare bandwidth, interconnects, cooling, power delivery, and optical links.
Exactly. AI performance is increasingly tied to the systems surrounding the GPU.
Which explains why networking companies suddenly became AI market favorites.
Now, Broadcom, Cisco, NVIDIA, and AMD are all competing to define the next AI networking standards.
The companies which originally built internet infrastructure are suddenly critical to AI again.
Because AI clusters increasingly resemble gigantic network systems, especially as AI models become larger and more distributed.
Money is flowing into networking, optics, cooling, and power infrastructure, not just GPUs anymore.
The AI race is no longer only about intelligence. It is also becoming a race to build the infrastructure capable of supporting that intelligence.
Every new AI breakthrough creates another engineering problem somewhere else.
And solving those problems may define the next generation of AI winners. Let's explore the world of AI